Welcome to Math 105, where we are talking about Chapter 2.2 Compound Interest and putting that onto your Excel sheet today. So you'll notice that we have our completed guided notes solution. So we're just going to be using just a couple of these equations just to type it into your Excel. So make sure that you have your sheets from class today in order to complete it. So we have your compound interest formula. So we have your interest, if we're looking at just the interest that was gained. Then we also have your future value equation as well. Now you'll notice that we have a lot of information over here. So we have PV, RTM, and such. So let's take a look at example one. It says, what is the future value of a $4,000 investment earning 2% per month or interest per month for 8 months? So we are compounding each month. It does not say that here. So this was a mistake on this particular example. It should say compounding each month or per month. Actually, it does say that right here. Interest per month. Okay, anyways. So let's just see. We said we have $4,000 for your present value. Again, I want to maybe convert this, not that, into a monetary value. We have rate as 0.02. Oops. Come on. Our time we said was 8 months, and it's okay that we're going to keep this as 8 because these two are in months. That is perfectly fine. And then we are compounding each month. So monthly compounding periods, well, there's 12 months in a year. No, the compounding period does not have to match your rate or your time. However, your rate and your time still have to be in the same units. So then when it says M times T, we're going to say equals. Every time we want your cell to do some sort of calculation, we'll hit equals M times T. Then over here, it says R divided by M. So we have equals R divided by M. Now, the reason why we're doing that is because you'll notice that over here in your equation, we have future value is equal to your present value times 1 plus R over M. We've done that calculation already. It's just going to lessen the amount of work that we put into the Excel formula for us. You certainly can still use R and M in your cells, but when it's asking for the division, your compounding period, or sorry, your compounding rate, we're going to be using R over M. Now, when it says M times T, right, this is this part right here, this 96 values, this is your compounding period. So over the full time, how many compounding values do we have? So when we go to type it into your formula, we have future value. So we want to hit equals. We're going to select your PV amount here times parentheses 1 plus, and again, instead of doing R divided by M again, we'll just click this value here, parentheses, and raise to your compounding period, raise to the M times T. A much easier equation than if we were to try to do the whole thing over. Now you notice that we want to put this again in some sort of currency or monetary value. We don't need such a large decimal value, maybe 3 to 4 would be a good amount. What it says your interest, and you'll notice actually before I move on, your future value, right? Notice that we had to do all of this work by hand and then punch it into your calculator. Your future value equation has already done that for us. We have 4693.42, and just by putting that into Excel and clicking what we want, it has built it for us. So now when we're talking about the interest, want to hit equals, and your interest formula for compounding specific is taking your future value and subtracting your present value. Your future value minus your present value. So if we compounded, if we were interested in how much compound interest we had earned over this duration, it would be about $693.42. Now, the reason why we want these Excel sheets up and ready is that when we go to enter in some other formula, right, we can actually, or not formula, but other information, we can actually just have it calculated for us. So if we did it again here, So to find the future value after 5 years, so T we can change to 5, and notice that as we change it, your values will change, of a $10,000 investment. Again, that changes all of your values, earning 6% per year. We have years and years, so that no conversion is needed. 0.06. Interest with interest reinvested every month. So again, that when it says reinvested every month, that's meaning it's going to be compounded every month. So we can keep ours as 12. And you'll notice that, again, your future value here is $13,488.50. This is where your equation, your answer is going to come out to be, which we had it right here as well. And then again, if you are interested in your interest that has been earned over that lifetime, over that period, it would be about $3,488.50. Now let's try it again, but this time we're going to swap it where we actually don't know your present value. And we want to figure out what is your present value given some of this context. So notice that here we have your present value is equal to future value divided by 1 plus r over m raised to the mt. Now we did it in your calculator where we kind of used the fraction button, which you'll see here. We also learned how to do it in your programmed calculators as well for a TI-89, or sorry, a TI-84. So again, we're going to learn it here with Excel. So it says Megabucks Corporation is issuing a 10-year corporate bond paying no interest during the lifetime, but promises to pay their maturity value at the end of 10 years. How much would you pay for the bond with a maturity value of $10,000? So they're not telling us specifically that the maturity value is your future value, other than I put it in our notes here. But think about somebody who's mature. They're a little older, they're a little bit further on in the future, right? So maturity is talking about some end value, which we said we have $10,000 here at the end. We want to know how much do we put into it to get this $10,000 out. So again, I'm going to put it as a monetary value. We have your rate at 6% or 6.5% annually. So annually is talking about a year. So let's see, 0.065. T, it says 10 years, those match. And then when it says compounded annually, that would be just the one time a year. So we'll do M times T. So M times D. We'll do R divided by, oh, come on, R divided by M. And if we wanted, we could also go ahead and do your interest. We take your future and we subtract it from your present value. So right now it's just showing 10,000 because there's nothing being subtracted. So now let's go and hit equals, and we'll type in this formula, also this one that we had seen from before. So we have equals parentheses, or nope, equals your $10,000, your future value, divided by parentheses 1 plus r over m raised to the m times t. So we needed to put in $5,327.26 in order to get $10,000 out under those conditions. All right, so hopefully we can add some flair at the end when we finish completing your simple and your complex interest. Things like that could be changing some of these values to make sure that there's no crazy decimal places. Everything has monetary value. Things are highlighted. Maybe you change the font, or maybe you make like a little note to yourself as to what we did, especially what we did with your goal seek from the previous video where we looked at how to figure out some of these values with just an unknown value.